and that's kind of obvious. Well, when you have x plus y to the first power, you're going to get x plus y. That's also obvious. Okay, and then what about when we raise x plus y to the second power? That really means x plus y times x plus y. Okay, and when you use distributive property to multiply, you're going to get x squared, and then you're going to get xy, and then y times x is going to get another xy, and then y times y is going to give you plus y squared, and this becomes x squared plus 2xy plus y squared, and that's what this is. And then if you keep doing that and multiply, let's say we take x plus y to the third power, which means we take this answer right here, multiply by another x plus y using distributive property, you're going to get that. And then we're going to take x plus y to the fourth power. So that means we're going to multiply x plus y times x plus y times another x plus y, and then take that answer, multiply by another x plus y, okay, which takes a long time, but you get this answer. And finally, when you take an x plus y to the fifth power, that means you're going to take whatever this answer is, you're going to multiply by another x plus y, then you're going to end up getting this answer. Now, the question is, what will you get when you take an x plus y to the sixth power, which is not stated on this Pascal's triangle? So I'm going to show you the trick and the pattern of the Pascal's triangle. So, let me clear that. Alright, so let me show you that when you have x plus y to the sixth power, we can use the information that we have on the top, okay, and then come up with it rather than using distributive property multiplying everything. So let's look at the pattern first. When it was for the fifth power, x had a fifth power, and then at the end y had a fifth power. Okay, so obviously when it's sixth power, then you're going to have 1x to the sixth power, and then we know at the end we're going to get 1y to the sixth power. Okay, what about the middle terms? Well, notice there's a pattern here too. Okay, so it was fifth power, then x became fourth power. It means it went down by 1. And then y came up by 1 power, and then x went down by another 1, and y power came up by 1 more, and x power on the x kept going down, the power on the y kept coming up, power on the x became 1, and power on the y became 4, and then finally power on the x became 0. That's why we didn't see that anymore, and then y became fifth, and then that was the end. So let's go ahead, write those out. So I'm going to have plus, my x is going to be to the fifth, y is to the first. And then I'm going to have a plus, I'm going to have x is to the fourth, and then y is to the second. Remember, all the powers in this one has to add up to 6, whereas in the previous one all the powers added up to 5. That's 5, that's 5, that's 5. Okay, so that means next term is going to be x is to the third, and then y is to the third. X keeps going down. Let me erase this a little bit, create a little bit more space for myself. And then my x is going to go down one more, so x is to the second, y is to the fourth, and then my x is going to go down again, x is to the first, and y is to the fifth, and then finally y is going to be to the sixth, and that's going to be the end. Only thing that's missing is the numbers in the front. That's why I left some space. Okay, how do you get these numbers? Well, the first number is always 1, the coefficient, and the last coefficient is always 1. But what about the middle ones? So to get these coefficients, all I'm going to do is I'm going to look up here. I'm going to add the one before that to get the second one. So that's going to be 6. Then to get the next one, I'm going to look at that one, add the one before that, and that's going to give me 15. And then to get the next coefficient, I'm going to look at this one and add the one before that, which is going to give me 20. And then to get the next one, I'm going to look at 5, add it to 10, which is going to be 15. And then to get the next one, I'm going to look at 1, add it to 5, which is going to give me 6. And that's it. Now, notice that this is 6th power. I have 1, 2, 3, 4, 5, 6, 7 terms. So I always get one more than the whatever the binomial I'm raising it to. Okay, so let's do x plus y to the 7th, just using what I have. Obviously, I'm going to have x to the 7th plus. How do I get this number in the front? I look up, add the coefficient before that, which is going to be 7. So look, 6th power had 6 as a coefficient as in the second term. 7th power is going to have 7 as a coefficient in the second term. 5th power is going to have 5 as a coefficient in the second term, so on and so forth. Okay, what happens to my power in the x and the y? X goes down, y comes up. So x to the 6th, y to the 1st, plus. To get this number, 15 plus 6, which is 21. X goes down, so x is to the 5th, y is to the 2nd. The powers always add up to 7 in this problem. Okay, plus. To get the next number, look up, add the one before that. That's going to give you 35. And then x is going down, and y comes up. To get the next one, 15 plus 20, that's 35. Okay, x goes down, y comes up. Plus, to get the next one, 6 plus 15, which is 21. Okay, x goes down, y comes up. Plus, to get the next one, 1 plus 6, which is 7. X goes down, y comes up. And then finally, the y is going to be to the 7th. Okay, so this is known as Pascal's triangle. You can keep on going. You can get x plus y to the 8th. Okay, and then you can get x plus y to the 10th, so on and so forth. You don't have to use distributive property once you see the pattern. But I'm going to do one with a minus in it, so I will show you the only difference. Let's say if you have a minus in the middle rather than a plus. Okay, if there's a minus in the middle, then again, we have the same game, x is to the 8th. Okay, now when it's a minus, the signs alternate. Plus, minus, plus, minus, plus, minus. Or, if you don't want to alternate the signs, then do this. Okay, use plus for everything. Okay, except, since y is negative, okay, just put that in parentheses. So, sometimes it's just easier. So, let's do it that way. Okay, so now I'm going to get 7 plus 1, which is 8. I got x to the 7th, negative y to the 1st. Okay, because y is negative. Now, if you didn't want to do that, then you can just alternate signs, plus, minus, plus, minus, plus, minus. Okay, so then I have a plus, and then 21 plus 7, which is 28. X goes down, negative y comes up, plus 35 plus 21, which is going to give me 56. X goes down, negative y comes up. Okay, now as you can see, this is going to be a negative answer because this is an odd power. Okay, so whenever you have an odd power, you're going to get a negative answer. That's why the second term ended up being negative, because of the negative y to the 1st power. Okay, alright, let's finish this off. To get this next one, we'll add 35 plus 35, which is 70. X goes down, y, negative y comes up. Make sure you put parentheses around the negative y, and then that becomes 4 plus. Okay, 21. Notice 21 plus 35. 35 plus 21. We had that before. So the numbers repeat also. So this becomes 56. X goes down. Negative y comes up. And then plus. Okay, what's 56? Then you're going to get 28. 28. X goes down. Negative y comes up. And then plus. And then 8. 8. X goes down. Negative y comes up. And then finally y to the 8th. There it is. So if you don't want to write it like this, then you can change, you can erase. You don't have to put negative in here. You can change this into a negative. Okay. And then every place you see an odd power, which is here, change that into a negative. And then change that into a negative here. I'll put those in a second. Change that into a negative. So I'm going to go back and I can do it this also. A minus here, and a minus there, and a minus there, and a minus there. So alternate plus, minus, plus, minus. Okay. These will always be plus because even powers. And so let me erase these even powers, because when you square something, raise it to an even power, it will stay positive. So those will all be positive. Even the last one will be positive. Okay, so they notice that they alternate. Okay. Now one more thing you need to be concerned about, and that is what term it is. Now 8 power means I'm going to have 9 terms. Okay. Now look, on the 9th term, y has a power of 8. On the 8th term, the y has a power of 7. On the 7th term, y has a power of 6. Okay, so y always has one less power than whatever the term is. Okay, so if I asked you, okay, state the 5th term, then you know y will have a power of 4. And then x will also have power of 4 because they have to add up to 8 in this particular problem. Okay? And then the coefficient, obviously, is 70. So this is the 5th term. Let's check. First term, second term, third, fourth, 5th. There it is. This is another type of series. This is a binomial expansion, but there's a shorter cut than this one, and we'll do that tomorrow. Okay, so let's do a few problems, examples that we have here, and then we're done. Okay. So this is not that hard. Alright, let's start with, let's say they want that. Okay, you have a 2 minus b to the 4th, and they want me to find the second term. Okay, second term means my negative b will have a power of 1, 1 less than whatever the term is. And then that means my 2, which is my first term here, okay, will have a power of 3 because my coefficients have to add up to a 4 in this particular problem. Now what about the number in the front? Well, 4th power, and there's my 4th power. Okay, so in the second term, which is this one right there, my coefficient is 4. So that's it. That'll be 4 times 2 to the 3rd times negative b, which I simplify there. This becomes 8. 8 times 4 is 32. 32 times negative b is negative 32b. And that's the final answer. Alright, let's do another one here. So they want the third term. So the third term of y plus 3x to the 3rd power. Okay, So you need this Pascal's triangle. Alright. So the third term, the 3x, which it acts like the second term here, will have a power of 2. And then the y will have a power of 1, because these two have to add up to 3. Okay, what about the coefficient? So on a third power, go back over here, look at the Pascal's triangle. Third power, the third term, which is 1, 2, 3, will have a coefficient of 3 in the front. When I simplify this, I'm going to square this 3, which is 9. 9 times 3, which will give me 27. X to the second y. And that is the third term of this expansion. Alright, so let's clear that, and then let's do some of the bottom problems here. Okay, let's start with 11. Let's expand that completely. Okay, so I have a 2b minus a to the fourth, okay, and that is raised to the fourth power. Alright, so I'm going to get the terms and then I'll get the coefficients later, because my coefficients are coming from Pascal's triangle. Or you can go the other way, you can get the coefficients and then get the terms. Or you could do this both at the same time. So let's do this. Let's do it all at the same time. Just cut to the chase. I got a 1, and then I have a 2b to the fourth, because that's the power I'm raising that to. And then I have a plus, or since this is a minus, we're just going to alternate. Okay, so that's a minus, so we'll go minus. And then I have a 4, and then I have a 2b to the third, and then a to the fourth. That's my second half of that problem. And then I have a plus, because I'm alternating signs because of this minus right there. And then I have a 6. There's my 6. And then I have a 2b to the second, and then I have a to the fourth to the second. And then I have a minus, and then I have 4 is my coefficient, and then I have a 2b to the first, and a to the fourth is to the third. And then I have a plus, and then I have a to the fourth. Oops, where did that b come from? A to the fourth is raised to the fourth. And that is the complete expansion. Okay, so let's do one more. Okay, let's take that. Okay, again, we're going to the fourth power. Or, you know what? Let's just make it hard. Let's do 16 instead. This will be the last one. Okay. Clear this out. Okay, so we are going to expand 2y to the fourth plus 1 to the seventh. Okay, but I need coefficients. Where do I get my coefficients? I have up to 5 right now, so I need some coefficients down here. So maybe I should just move this over here. Let me move it down a little bit. Let me rewrite that. 2y to the fourth plus 1 to the seventh. Okay, and then let me use this space here to make up my coefficients that I'm missing, because I'm raising it to the seventh power. Here we go. Let's finish building up this Pascal triangle to the seventh power. So x plus y to the sixth will be 1, 6, 15, 20, 15, 6, and 1. And then x plus y to the seventh will be 1. Add these two, which is going to give me 7. Add these two, which is going to give me 21. add these two, which is going to give me 35, add these two, which is going to give me 35, adding these two is going to give me 21. It's going backwards now, and then 7 and 1. Okay, so those are my coefficients. So I'm going to have 1, that's my first term, which is going to be 2y to the 4th to the 7th, and this is a plus, that means everything gets a plus. And then I have a 7 times 2y to the 4th to the 6th times 1, which is my second term, and then a plus, my coefficient is 21, and then I have a 2y to the 5th, and then I have 1 to the 2nd. Remember, my powers always add up to 7 in this one. Okay, plus, and then I have a 35, and then I have a 2y to the 4th, 1 to the 3rd, and then plus again another 35. I'm getting these numbers here from the Pascal's triangle. Okay, and then I have a 2y to the 4th. Oops, I didn't raise that to the 3rd, did I? Let me go back and fix that. 2y to the 4th to the 3rd, to the 4th. Okay, so 2y to the 3rd, and then I have 1 to the 4th, and then I have a 21. Okay, so I have a plus 21, and then I have a 2y to the 4th is raised to the 2nd, and then I have 1 to the 5th, and then plus I have a 7, and then I have a 2y to the 4th, keep getting to it right, the 4th, okay, 4th, and that is now raised to 1 power, and then I have 1 to the 6th, and then finally I have 1 to the 7th, and that is the binomial expansion. Either that or multiply this out 7 times. Okay, so that's even longer than doing this. Okay, so make sure to print out this worksheet and bring it with you tomorrow. That's it.